Good day everyone. Today I'll be teaching you how to use Siemens TIA Portal and create a basic application, PLC application, and download it on your PLC. We will be only discussing here about bit instructions and how to use them and apply in a specific PLC and how do we try to apply that on the mechatronics trainer in the SAP. First, let us try to open TIA Portal V14. Remember that you will be using AnyDesk to control a remote PC in LaSalle since we will be using the Siemens TIA Portal version 14 that is installed in the laptop and connected to the PLC or to the mechatronics trainer in our school. Next, we will be creating a new project. As you try to create a new project, you type a project name. I'll be putting this one as basic instruction. This will be our first activity for this particular laboratory experiment. Click on create. Then the next thing that we need to do is to configure a device. Click configure a device. Then next we will be adding a new device. As we try to add a new device, we will be selecting Simatix S7-1200. Select the CPU. Then select an unspecified CPU. Select this type of PLC. Then click on Add. So it will try to create the unspecified CPU, and we will now be going to what we call the project view. On the project view, you will see that the device is not specified. It's because we need to detect our PLC, which is in our institution. We will be using the auto detect feature of the portal, so that's why we will be using this unspecified CPU for now. Now to specify the CPU that we will be using, we will be clicking on detect. Once that we click on detect, we will be now going to a dialog box which sets the PG-PC interface. Let us try to select PNIE, which means Profinet for the type of PG interface. And for the PC-PG interface itself, the one that is connecting to the PLC and the PC, we will be using the Ethernet controller of our laptop, which is Intel Ethernet connection. Once that these two are selected, we will now be starting our search. As you try to see or try to look at the online status information, it tries to search for a PLC and has found our PLC, which is with the IP address 192.168.0.1. Once the scanning is completed, we will now be selecting the device and click on detect. It will now automatically detect our PLC and its expansion slot. As you can see, we have now our Siemens S7-1200 and its proper CPU together with the detected expansion slot, which adds more inputs and outputs in the particular mechatronics trainer. But before we proceed to the programming per se, let us try first to configure something in the expansion slot. In the expansion slot, as we try to go on properties and click on I/O address, we will be noticing that our input and output addresses starts with 8. Based on our diagram given, this must be changed into 2, since our input and output expansion slots will be using 2.0 up to 2.7 for both input and output addresses. That's why in our expansion slot, we will be changing 8 to 2. Same goes to the output addresses. Once that change, we will now be minimizing this one. I will now be uploading or downloading to the device the hardware changes. So I'll be right-clicking on the expansion slot, download to device, then hardware configuration. We will wait for a bit. As you can see, it will now start to load. Be mindful that this protection says here that the protection from unauthorized access. Since we are using many laptops for accessing the PLC, we will be disregarding this for now. So I'll be clicking this one, loading, and now it is loading to the device. After that we have loaded, we will be clicking on Start All, then Finish. Next, we will now be proceeding to the program. Now I'll be clicking on the program blocks, then add a new block. When we try to add a new block, we will be clicking on the function block, FC. Take note that the language that we will be using is LAD, which stands for Ladder Logic Programming. Select this one as automatic, then click on OK. Now we are on an empty ladder program. We will now be creating a basic ladder program by adding a normally open contacts and a coil. So these two are one of the basic bit instructions that we have discussed in the previous lesson. Notice that they have question marks at the top of their respective symbols or instructions. It only indicates that we will be putting a specific address. That specific address points out to either a physical address, either input or output, memory addresses, which is inside the PLC. For now, in this activity, we will be using a memory address on the open contacts and an output address in our output coil. So, in our normally open contacts, I'll be clicking on the question mark and I'll be putting a memory address of M0.0. And on the output address, I'll be using a green lamp which is located at the address Q2.0. Again, the list of addresses could be found in our manual. Now, once that this two has been verified and checked, now we will be proceeding to compiling. So click on Compile to check for any errors. To look if there are any errors, I'll be lifting up the status symbol or the status screen, check on the compile, and as you can see, our programs has 0 errors and 0 warnings. It means that our program is okay. Now is the time for us to upload the program. But before that, we need to first put the block where our ladder program is designed and put it to our main block. To do that, I'll be double clicking on the main block, select an empty box and drag it to the ladder diagram as shown. Now, it has again a question mark. It means that it asks for a particular block name, and we will be putting this one as block 1. It auto-detects for any available blocks in a particular program block. So I'll be clicking on block 1, and now our program is complete. Now is the time for us to download the program. Click on download to device. Continue without synchronization. Then I'll be stopping all the modules or the PLC. I'll be stopping the PLC while loading the program. It's now loading its configuration. Then I'll click on Start All. Start All must be checked and click on Finish. Now I'll go back again to block 1 and click on Monitoring On and Off. It means that we will be checking our program online using this software by clicking on this particular icon. Notice that there is a broken line in the coil. It indicates that there is no power or no signal flowing to this particular coil. You have seen this green line or this green line. This green line indicates that there is actually a connecting power to that specific line. In order to complete a closed circuit just like stated in our ladder diagram, the normally open must be closed. In a PLC, to do that, we will be right-clicking on the normally open push button or the normally open contacts. We will be modifying it and placing it from 0 to 1. Notice that we have a full closed circuit connection, indicating the green line from the left side down to the coil at the right side. To check whether in our physical device, if the green light has lit, we will be clicking on Start, go to Camera, and as you can see, the green light has lit, indicating that our program has synced already to our device. Please take note that the yellow light here signifies that the system is powered on. So only the green, red, and the white light at the top portion of our panel signifies the light which is connected to the PLC. Now, to check whether the light will turn off when I modify the bit from 1 going to 0, again, I'll be going back to our ladder program. Since we are now still on monitoring, right-clicking on the contacts, modifying it, and changing it back to 0. Now notice that it becomes again a broken line. Let us look at the camera if the light has turned off. As you can see, the light has turned off, meaning that the signal coming from the memory bit has been deactivated, making the PLC sends the signal to our lamp to turn off. Again, thank you very much for listening, and this should be the end of our demonstration. Good day.